Hi, and welcome to the Light Reading webinar, Is NetConf Ready for Prime Time?, where we're going to be discussing what's holding back the adoption of NetConf Yang and how to accelerate it. Well, as Becky said, my name is James Crawshaw, and I'm an analyst with Heavy Reading. Presenting with me today will be Praveen Mirchandani from One Access. He's the Chief Marketing Officer there, and I'll be giving a brief introduction. So the agenda will be myself giving the brief introduction, and then I'll be handing over to Praveen for some more detailed discussion on the various aspects of NetConf and Yang. We aim to leave 15 minutes for Q&A at the end of the webinar, so please submit your questions as we go through today's presentation via that Q&A widget on the On24 website. So, SNMP, as you may know, was developed back in the late 80s by the IETF for network management. But information was pretty difficult to represent in an organized way with SNMP, and there was also a lack of an automatic discovery process to find a device's management information base. All of that meant that discovery had to be done manually, and that made configuration management very complicated. So ultimately, SNMP has mainly been used for monitoring, and configuration is typically done via vendor-specific command line interfaces. However, CLI needs scripts, and the output of those scripts can be unpredictable, and some estimates suggest that as much as 60% of outages are caused by humans mistyping into their consoles the configuration scripts. NetConf Yang is the industry's latest attempt to try and crack the network configuration problem. NetConf itself is an XML-based network configuration protocol that brings transactionality to network management. If any step of the end-to-end provisioning fails, and if there's a need to roll back and undo previous actions and revert to the original configuration, you need this concept of transactionality, which isn't supported with CLI scripts, but it is one of the key benefits of NetConf. So Yang, where does that fit in? Well, to be useful, NetConf needs a modeling language, and the IETF's Yang looks a bit like C and can be used to model configuration data and state data of network elements. The figure on this slide shows how NetConf is used to deliver those Yang models to the various network elements. The Yang data models themselves describe devices and services and are transported via the NetConf protocol. So why is this relevant or important for NFV? Well, NetConf Yang is a key enabler of NFV, where services, remember, they can be designed at a very high level. They're independent of all of the complexities and device dependencies of the underlying infrastructure. And the dynamic nature of these virtual networks, with functions being spun up and changed continuously, is going to require highly automated management. The combination of NetConf and Yang gives operators that flexibility in the management of their network devices, both physical and virtual network functions. There are a wide range of SDN projects and industry organizations like the Open Networking Foundation, the Open Daylight Project, the Open Network Operation Systems Project, and the Open Platform for NFV, all of which are now promoting NetConf Yang as a universal southbound protocol for the configuration and management of both VNFs and physical network devices in SDN environments. SDN and NFV promise to change network operations through automation and open APIs, driving down operating costs and increasing the speed with which new services can be delivered. But many of those benefits can actually be achieved today without all of the complications of virtualization, simply by adopting a programmatic, standards-based way of writing configurations to any network device from any vendor, replacing the manual configuration of tens or even hundreds of devices that service providers have to currently undertake to deliver a service to an individual customer. Lots of vendors support NetConf Yang on their latest network devices, and that enables carriers to program the physical network functions that are residing on those devices and construct service chains between physical network functions and the cloud-based virtual network functions. NetConf Yang supports the automation of configuration across these different devices, and it supports transactionality. So as I said earlier, CSPs can be confident that either all of the configurations in a sequence are applied or the entire update is rolled back. So what's holding NetConf Yang back if it's so great? Well, I won't go into all of these details because Praveen will be addressing many of them in the presentation later, but in essence, key things that are holding NetConf Yang back are the install base clearly doesn't support it. There are some immaturity issues to do with Yang module standardization. There's some resistance to change, naturally, within telco engineering departments. There is some confusion between NetConf Yang and other technologies like TOSCA or REST APIs, and also some confusion about the difference between a Yang model and an information model. And hopefully we'll address some of those confusions on this webinar today. Finally, I'd highlight a lack of interoperability, both in a north-south direction between the network function and its orchestrator, as well as in an east-west sense between different VNFs and PNFs. So interoperability, as always, is an issue holding things back. In terms of our advice for operators, at a very high level, we'd say you should pick vendors that have got good support for NetConf Yang, mature data models, and vendors that embrace openness. You need to take an open multi-vendor approach, avoiding vendor lock-in. You've got to take a pragmatic approach to service migration. You need flexibility over the timing of the move to virtualized services. You've got to keep complexity low. You've got to think about using some tools to perhaps help build those Yang models using machine learning. There are various tools out there that can help reduce the amount of human intervention required in building Yang models. You've got to do all of the interoperability testing to try and work out if there are any immature data models and get your vendors to fix them. You've got to look at perhaps a middleware platform or some sort of orchestrator or CLI translator to connect to and configure all of the old equipment that you have sitting in your network. And finally, you need to build on the skill set of your operations teams, adding scripting to the skills that they already have to enable them to create those recipes that are needed for managing software-based VNFs. So that brings us to our first question poll, which is, what do you regard as the main two stumbling blocks to NetConf Yang adoption? And if we've set this question up correctly, you should be able to pick two answers out of the various options here, which I'll run through. Lack of legacy support, immature vendor Yang models, Yang skill shortages in the communication service providers, lack of operability, both north-south and east-west, and confusion between NetConf Yang, REST, and RESTconf, or the other confusion between TOSCA and Yang. Okay, hopefully we've got enough responses now, so I'm going to push them out to the audience so we can all have a look. What I'm seeing here is fairly evenly split, but we're getting a strong response for lack of legacy support, immaturity of Yang models from vendors is a concern, Yang skill shortages, then interoperability, and doesn't seem to be much of an, or to a much lesser degree, there's concern about confusion between TOSCA and Yang, and a bit more of a concern about confusion between NetConf Yang and REST or RESTconf. But hopefully our audience is already, the majority of them are not confused about the difference between when you'd use TOSCA and when you'd use Yang. But for those who are, I'm sure Praveen will be addressing that later on in his presentation. And with that, I'm going to hand over now to Praveen, who's going to start off talking about the drivers behind virtualization. Praveen, over to you.
Thank you very much, James. That was a great introduction. So hello, yes, I'm Praveen Mirchandani at One Access. I run the product portfolio as well as corporate communications for the company, and I have been one of the key leaders in the drive towards virtualization at the company, embracing those concepts as I think it's now 4.5 years ago when we started our journey. But let's take a look, as James said, let's take a look at the operator's viewpoint. So, One Access sells mainly to service providers, and we've had a lot of conversations with various service providers about what are they trying to achieve here. I think two key drivers really emerge. One is the need to deal with the exponential increase in data, and that there's no way that the traditional monolithic appliance can be replicated at scale sufficient to deal with that increase in volume of traffic. So they're really looking for the need to abstract software from the underlying hardware so that the underlying hardware can be very common and therefore made available at the sorts of scales that are required to deal with all of that data. But there's another driver, which is really this wish and desire to deliver network services on demand. By that, the real idea is to have a sort of portal that is available to customers where they can select the different types of network services in a very similar fashion to the way that they select cloud-based computing today, and that they could make that available to their customers. But both the need for software abstraction and the need to deliver network services on demand means that you need transactional APIs. And this is really where NetConf and Yang have come to deliver on that sort of vision. But there are some things that need to be addressed, and I'll hope to do that in the following slides. Now, one of the operators that I talked to made the interesting contrast between snowflakes. Snowflakes are very unique. Every snowflake has an individual pattern that can be isolated. And that's really not what is needed. One needs something that's much more consistent and indeed much more like a Lego brick. And this means that as well as the transactional protocol, you need consistent data models that describe the specific network functions that are being delivered. So, in order to be able to deliver on this promise and respond to the increase in volume and then respond to the need to deliver network services on demand, a number of changes have to come about in the delivery model for those network functions. As I've already mentioned, we need to move away from proprietary hardware to common off-the-shelf solutions, and at the same time move from monolithic appliances. By monolithic, I mean where the software and the hardware are fully integrated together to deliver a specialized device, if you like, for one or more network functions, but to abstract those functions into software delivered on the COTS hardware platform. But the implications are more far-reaching than that. I think one of the more interesting observations that I've seen in some of the developments in the industry is the need for vendors. Clearly, we still compete with each other, but the need for the vendors to collaborate much more energetically, much more vigorously through the development of ecosystems, through the development of demonstrating interoperability, be that north-south from the management or orchestration system to the specific devices or VNFs, as well as between VNFs, and to be able to highlight the resource consumption that they need so that when you select two or more different vendors on the same platform, on the same COTS platform, that they can actually deliver the functions in a smooth and integrated fashion. Clearly open, you've seen in many of the acronyms or many of the descriptions of the bodies that are involved in this effort, they almost all begin with the word open. but as some people have remarked, there are various degrees of openness that are available from the vendor community. But clearly one of the ambitions and goals of the operators is to avoid vendor lock-in and to minimize the dependency on any specific set of vendors. And of course, coming now to NetConf and Yang, to have script-based provisioning that allows and delivers those change configuration APIs. So let's take a look at the various provisioning protocols available. James has already made some remarks on SNMP and CLI, but I think this is actually quite an interesting comparison because you can actually achieve quite a lot with the current generation of classical provisioning and monitoring protocols. The zero-touch provisioning, a much used term in the industry, can be delivered by what is available today. And we can, of course, particularly with SNMP, get diagnostics and monitoring as well as with TR69. But it's really when you come to automation, when you come to transactionality, that you start to see the differences between the existing protocols and the promise of NetConf Yang. So clearly, NetConf Yang is XML based, which does make it human readable, although it's still quite a complex science, if you like, to deliver those scripts. But one of the key aspects of it is this separation of configuration and state data. One of the major criticisms of CLI and to a certain extent TR69 is the lack of predictability. You deliver a script or you deliver a configuration change, but because of errors, because perhaps of sequencing in the delivery of the configuration, you don't exactly know what the state that the target state is going to be at the end, and least of all, it's not very predictable. And of course, you can't determine the state often because there will be some difference in the running configuration as opposed to the actual editable configuration that is delivered. So this is the real strength of NetConf, which is its ability to deliver configurations on a transaction basis, as James mentioned, to be able to roll back if there are errors. So you can go from a target, from an initial target state to a target configuration state, and if you don't achieve the predictable outcome that you want, then you can roll back to the initial state. And you also have the ability to have multiple configurations on the device. So you could actually have potentially different target states within that device. And of course security, which most of the protocols provide, perhaps with the exception of CLI. But this gives you an interesting view of what you can achieve with the different protocols, with the emphasis on automation and transactionality, with NetConf being its principal advantages. So I don't intend this to be a tutorial on NetConf, but I do want to bring across some of the core concepts and illustrate some of the commands that are available within NetConf. As we've mentioned, it's XML based on remote procedure calls. And what you do is you use a client, which is the external manager, if you like, that establishes a session to the underlying device or VNF. And this, through that session, you deliver the various configuration changes that you want to achieve. As I've already mentioned, you have two classes of data, configuration data and state data. And NetConf has a set of standard or basic operations that are available or mandatory for all people that support NetConf Yang. Having said that, there is the ability to advertise additional capabilities. So when the client sets up the session, they can ask if those additional capabilities are available, and then they can be used by that client. And the other key aspect of NetConf, as James already mentioned, is that you do need a data model. You need something to represent the basic configuration state, the objects that are being transacted on, and it is this that is described in the Yang data model. so that you can undertake protocol operations on specific network functions, be they in software or in hardware. And just to illustrate some of the commands that you have, as you can see here, you can get the configuration from the data store. Remember that there are potential multiple configurations that can be stored there. You can edit, you can copy it should you want to, or delete. In order to prevent inadvertent changes, you can lock as well as unlock, as well as get the current running configuration. There's a graceful way to close a session, and of course, if there's some inadvertent event that is happening, you can force the termination of a NetConf session, and then it will revert to its previous state. So those are some of the base transactional characteristics of NetConf, and they're really there to facilitate A, the automation, and B, the transactionality of the protocol. So we've talked a little bit about NetConf Yang and why it is seen as a sort of next generation protocol, as a sort of nirvana to deliver on the requirements of the operators going forward. But let's take a look at some of the stumbling blocks that are out there and the sort of status of the industry. So James has mentioned some of these: lack of legacy support, and I saw that was one of the key things that people identified in the first poll question. Maybe I could make a couple of remarks on that. But NetConf Yang, because of its architecture, because of its design, actually requires a fundamental change in the software architecture on devices. This means more memory to start off with, but it also means that the actual underlying software architecture has to be converted into Yang objects, each of which can be transacted on, and each of which has to be quasi-independent. And that requires the software to be completely redesigned. So, and in order to allow the transactionality, to allow different configurations to be stored on the device, as I've already mentioned, you need more memory. So traditional appliances or network devices have typically been optimized to support the current or legacy software architecture that is on the device, and typically have been designed to minimize the use of memory. And as a result, that means that legacy devices can rarely be transitioned to support NetConf Yang. You need a new software load, and in particular, you need more memory than might be available on those legacy devices. That's why typically it's next generation devices that are needed in order to support NetConf Yang. I think it's true that standardization is quite immature, the early initiatives and the standards committees to try and define common data models, standardized data models, are still at an early stage, and it has been the vendors that have gone out there and delivered models that are being used in the current sets of trials and initial services that have been launched with NetConf and Yang. Skill shortages is a major issue, and I think one of the reasons is, and NetConf and Yang, NetConf as a protocol and Yang as a data model are in themselves relatively easy to understand as concepts, but they're designed to model the complexity of a various set of network functions. And getting that complexity modeled and to automate it requires a tremendous degree of energy and effort, and indeed skills, on the part of the operators. I think this is one of the key issues that the industry is facing. And it's not just the operators, the vendors themselves are all competing for resources that will enable them to do this. We talked about the different APIs that are available. One of the things that I've seen is that many virtualized functions are available with perhaps just a REST API. And although REST does allow you to access underlying Yang objects, quite often those underlying objects or the network functions are not modeled in Yang. So whilst you can get integration from an orchestrator to a network function via a REST API, you don't get the full transactionality that is available with NetConf Yang. Interoperability, yes, that has to happen. And typically it's happening more or less on an anecdotal basis in various POCs and trials, and there are some initiatives in the industry to demonstrate interoperability between the various vendors. So, there's a big lab out in Berlin in particular where a lot of that work has been going on. I often get the question, what's the difference between TOSCA and Yang? They're both ways to model data. But it seems that certainly for network functions and for network devices, Yang is really proving to be the method of choice for most of the industry. TOSCA is quite often used at a slightly higher level, often to define software applications. And I know, for instance, that AT&T is using TOSCA to describe the package in which a VNF is delivered and the characteristics of the package, but then is insisting on Yang to describe the models and objects that are within the specific network function, which is an interesting way to do it. But certainly for network functions, Yang is the principal method used in the industry to describe those objects and how to use transactions to manipulate them. So where is the industry? So I think a number of operators around the world, principally the very big ILECs, have launched their first virtualized services. Interestingly, these have not been on common off-the-shelf systems. They've been on so-called grey boxes, where there is an aspect of proprietary hardware to accelerate one or more network functions, but on that same box there is the ability to load a virtualized network function that can be then chained with the PNS, as they're called, the physical network functions that are associated with the proprietary hardware. I think this was a very pragmatic approach. Those boxes existed. The white box concept had not been fully proven, and in particular there was a problem with white boxes, which to a large extent exists today, which is their cost. One of the key issues is that in the initial efforts to virtualize network functions, a lot of those network functions are extremely heavy. By heavy, I mean they need lots of processing power, and they need lots of memory, and in many cases lots of storage, which means that the white box has typically had to be a very capable white box using a Xeon D or in some cases a Xeon E processor rather than the more commodity-based Atom processor. So this means that the cost of the white box has indeed been a stumbling block. But it's not the only reason why grey boxes have moved. It was just they were available, typically from vendors that were already integrated into the management systems and IT systems of the operators. A big issue has been MANO, management and operations. As I've said, very complex to model all the complexity of network functions and the way to set them up and to manage them and to deliver them and orchestrate them. And that has proven to be an extremely big task for the operators. And to a certain extent, the task has been complicated because there are competing initiatives within the industry. So there is the so-called open source MANO initiative sponsored by Etsy MANO if you like, which has got a lot of support. I was at a conference, Network Virtualization Europe, recently, where Telefonica, who has been very much in the vanguard of promoting open source MANO, was there delivering lots of speeches on it. And ONAP was not at all mentioned apart from a couple of questions, whereas I was at another summit in North America just a few short weeks before that, when ONAP was being promoted, in this case by AT&T. as the way to go forward. And there are some fundamental differences in the approach between open source Mano and ONAP. In particular, ONAP is looking, perhaps not today, but is looking to do away with EMSs and to do away with virtual network managers and to integrate all of that into the Mano. So that's quite ambitious. But on the other hand, ONAP has production-ready code, which really does facilitate the delivery of services today. Open source Mano, although there is still there's a lot of energy and effort being put into it, as far as I know, and I may be wrong here, it's not production ready. Key vendor support for NetConf. Although there is widespread vendor support, because it is such a large undertaking to convert your software architecture to support NetConf Yang, it means that this has, for the most case, been reserved to the very large vendors who were able to invest the resources there. I should, as an aside, say that although OneAccess is not a large vendor, we do support NetConf Yang, but we are seeing that some of the smaller vendors are struggling to undertake the development that is required to support it. There is, of course, the issue of how to transition the installed base, and there are a number of different approaches there. And then I think one of the other issues is, VNF support. Particularly at the volume end of the marketplace, it's difficult to identify the network functions that could be delivered for the volume end of the market. I mean, obviously the obvious one is security, but SD-WAN has come to a lot of prominence. But SD-WAN does not have to be a VNF, but one of the key aspects of it is its proprietary nature. And I know that a number of operators who have deployed SD-WAN have tried to find different ways to minimize the impact of its proprietary nature. Those of you who have been following virtualization for a while will know that NetConf Yang was promoted by a Swedish company called TLF, and really was chosen as the reference implementation by a number of the large operators around the world. I hope there's nobody from Cisco here, but because Cisco did buy TLF, there was a lot of shock and horror about that purchase and some worries at the operators. To their credit, Cisco has indeed kept it fairly open, and TLF is still seen as a fairly independent entity within Cisco. I think Cisco is recognizing the need to have an open implementation, but it is serving as a little bit of an advantage for the industry in that it is now it still remains the quasi-reference. So many operators have chosen to stick with the use of TLF, or NSO as it's now called at Cisco, and this does facilitate to a certain extent certainly north-south interoperability. And the focus really has been on-premise deployment. I think partly this is because certainly large enterprise, the economic argument of replacing multiple appliances with one white box, even if it's a very powerful white box, does facilitate that. But there are some issues in the data center, and one of them is the maturity of OpenStack. I know BT in particular has been quite critical about OpenStack's maturity and its scalability. So there's some issues to be solved there. And plus, when you do put VNFs in a data center, then you have to build those data centers in the first place, which of course means some upfront investment, quite significant, particularly if you're a large operator running international networks. So to cut a long story short, NetConf Yang is being deployed. It's being deployed principally today on grey boxes, with a move to white boxes being planned by the operators in 2017, certainly for the larger operators. TLF is a quasi-reference, and most of the focus, initial focus at least, has been on premise as opposed to in the data centers. Although data centers are being built, they are taking a long while to come on stream. So That's certainly how the industry, or where the industry is today, certainly as we see it. And I do trot around quite a lot of conferences, so these have been remarks and observations echoed by many of my peers and colleagues within the industry. So when it comes to migration, and migration is really a genuine big issue, one of the aspects of the deployment of virtualization is the relative immaturity of the MANOs. It's taking a lot of work to get them to work, to get them production ready. And so one thing you need to do is to anticipate that you need to coexist with legacy or classical provisioning and monitoring protocols alongside the move to NetConf Yang. So I think one thing that certainly we promote is the joint support of NetConf Yang alongside classical protocols such as TLI's TR69. So what that means is that you can start with CLI today if that's what you're used to doing, but then using the same network functions, be they physical or virtual, you can move to NetConf Yang when you're ready. It also means that you have an open choice, so you avoid vendor lock-in. I think scalability is a big issue. Remember, one of the big drivers for network virtualization is this need to deal with this tremendous amount of data. So in order to achieve that, you need the standard APIs, where I think we've made some good progress as an industry. But I think work in progress still very much in making sure that the data models are consistent. And then I think there are other stumbling blocks, in particular the need to re-engineer processes. The traditional waterfall method of introducing services doesn't really cut it. You need, I think the industry is more or less standardized on the term DevOps to describe this ability to intermingle different types of skills, particularly from IT, with an IT background and a networking background, in order to run in parallel, fail fast, get services delivered very, very quickly. And of course the need to insist on interoperability. So those are all of the things that we see in terms of thinking about migration. So I think at that point I hand back to you, James.
Yeah, thank you, Praveen. That's great. That takes us to our second question poll for today. And the question is, what are your top 2 concerns for NFV migration? Again, you can pick 2 responses here. And the concern options that we've given are lack of joint support for NetConf Yang and classical command line interface, such as TR069, lack of standard APIs, inconsistent data models, the need to re-engineer your operational procedures, or the need to adopt a DevOps culture within your organization. I'm going to assume that people have had time to answer. I'm going to push out the responses and see what people are thinking. So, this in the correct order? Not necessarily. I think the top response we seem to have is 58% of, or 50, not quite 58% of people, because we're picking 2 scores, but the highest scoring response is the need to re-engineer your operational procedures. That's the top concern for the migration to NFV. The other choices, there's a fairly even distribution. So, Praveen, is that a surprise to you that it's the changing or adapting your existing operational procedures is the big concern?
I think it's the big operator concern. I guess most of the audience here come from operators, so it's certainly I think the issue that they're facing day to day, and I guess there's a number of frustrations about that within the operator community. I think some of the other issues are also quite important, and the industry needs to address them. I'm not overly surprised by that answer, given the audience.
Great. Okay. We're going to move on to the final section of today's webinar then, which is indeed the audience Q&A.